One of the very common use cases for JavaScript in a web application is to validate the forms in your web page. For example, if you have a user registration form, you may have certain rules with regards to the type of characters which are allowed in the username field. You may also have a minimum password length, and similarly, you may have a number of different rules for each of the elements which make up your form. When the user fills in all the details in the form and then submits the information, rather than sending all the data over to the server side of your application and perform the validation there, it's usually far more efficient to do the validation on the client side using JavaScript. This is precisely what we will take a look at in this demo, for which we make use of three different files. The first, which you see on the screen in front of you, is called form.html, and this is just a simple HTML page which a user will be directed to once all the validation checks have been passed. At this point, we deem the form submission a success. In addition to this, there are two other files which we use in the demo. There is, of course, an HTML along with a JS file. So let us take a look at each of those in turn, starting with the JS forms intro.html. I'll just go ahead and paste the elements here. So you see here that this includes a body element, and we set a background color for this using a hexadecimal value. And then there is an h2 header within that. Following that, we have a form element. Within this, we will have a number of different input fields where we will collect information from the user as though they are registering to open an account at a bank. But first, take a look at the attributes which we have for this element. So we assign it a name of my form, and then in the action field, we point to the HTML file which we need to navigate to upon a successful submission of the form. In our case, this is the form.html we just took a look at, which is available one directory above. Then there is the onSubmit attribute, whose value is the JavaScript which needs to be executed when the user hits the submit button of the form. We will get to that submit button in just a moment. But you can see here that we invoke a validate form function, and this is something we will define in the accompanying JS file. That is where we will perform some basic form validation, and it will return a Boolean value depending on whether the validation has passed or not. So inside our form, we first have a header which says that this is a registration form, and then we introduce two other form elements. The first of these is an input, specifically a text input, and this is where a user will enter their username for the registration. We have some placeholder text, which is your username, and we assign this element a name of uname. Next, we have one more input, and this is going to be a numerical input. This is where the user will enter their age. We assign a name for this element of age, and we also set the required attribute, which means that the user is required to supply a value for this particular field. Beyond the username and the age, we introduce some radio buttons and also some checkboxes. For the radio buttons, we present the user with two different options, and this represents whether they are residents of the state or not. So the name for this element is residency, and you can see that there are two different values which are represented. One is for resident and the other for non-resident. You'll observe that the checked attribute appears for the first of these radio buttons, which means that the resident value will be checked by default. We then have some checkboxes whose input type is checkbox, and we set this a name of account type. You can see here that this represents the type of accounts which the end user wishes to open up with the bank, and given that these are checkboxes, they can select multiple values. You'll observe that the checked attribute has been specified for the checking account type, and this is the one which will be selected by default. We're not quite done with our form, however. We have one more input field at the end, which is in fact a drop-down menu, and in HTML, this is a select element. So you see here that the ID has been set to nationality, and we have 6 different options listed here, ranging from Australia to the USA, And each of these options has a numerical value assigned to it, ranging from 1 through 6. You can also see here that the value of 4, which represents India, is the one which is selected by default. So these are all of the input fields for the form. But at the very bottom, we include two buttons as well. In HTML, these are also input elements. The first of these is a submit button whose type is submit, and then the text which appears on it is also submit with an uppercase S. Similarly, we have a reset button right next to it. And at the very bottom, we introduce a script tag which points to the JavaScript source file, and inside that we will define the validate form function, which will be invoked when a user hits the submit button. That is something we will get into in the next video. In the previous video, we defined an HTML page for our application which included this form, and there are various input elements here which we will access from our JavaScript source file and then perform a simple validation. So heading over now to the JavaScript file, I am going to define the validate form function, and to start with, we can retrieve each of the different input elements within our form. So all of the forms in a particular document are accessible using the document.forms object. Since it is an object, we can use it in order to access a specific form using its name, which is why within square brackets, we specify the name of our form, which is my form, within quotes. That form in turn is an object, and we can access the different input fields within that, once again using the name. And in order to retrieve the username field, we specify its name of uname, once again within square brackets. So this retrieves the element itself. However, to access its value, we get to its value property, and this we assign to the variable uname. Similarly, we can retrieve the value of the age which was specified, and also the value of the residency, which is specified using a radio button. All of these three fields had single values, which is why we were able to access those values using similar methodology. The account type, however, is a checkbox, which means that multiple values can be selected. And in order to retrieve the array of selected values, well, one way to do it is to invoke document.querySelectorAll, in which case we specify the CSS selector corresponding to the checked checkboxes. Note the argument which we specify to querySelectorAll in order to retrieve the checked checkboxes. And lastly, the nationality is retrieved using syntax similar to how we retrieve the username, age, and resident status. So now that we have retrieved all of the input which was submitted by the user, it is time for us to perform some validation of that input. Starting with the username. Here we check whether the length of the username is less than 6, and if it is, we will issue an alert saying that the username needs to be at least 6 characters long, and this validate function will return a false value, which means that the validation has failed. On the other hand, if the username is greater than or equal to 6 characters, we head over to the else block, where we initialize an array of selected accounts, and this is the array in which we will store all of the values of the different account types which the user wishes to open. So we initialize this to an empty array, but following that, we iterate over the account type array and then push the value of each account type into the selected accounts array. Once that is done, we will formulate a message which needs to be conveyed to the end user via an alert message, and this includes all of the details which they have supplied. So we issue this alert message, and following that, we return true to convey to the form that the validation has passed. So the only real validation which we are performing here is to check that the username has a length which is greater than or equal to 6 characters. And if that validation passes, we will issue this alert message. We will perform some additional validations a little later in this course, but for now, let us save down all of our HTML and JS files and then load the JS form intro.html in the browser. So our registration form has popped up here, and we can see all of the different fields within our form. Importantly, observe some of the default values for the different form elements. For the username, we have the placeholder text of your username. And then for the residency radio button, the value of resident has been checked, as has the value of checking among the account type checkboxes. Now I'm just going to pop up the console in the bottom of the page. And from the Elements tab, you can see exactly what our page contains. So we have the head element, and then within the body, we have our form element as well. And when we expand the forms, you can see the individual elements which make up the form itself. Well, it's now time for us to begin playing around with our form. And heading over to the username field, let us now enter a value. So I'll just specify a name of John, which of course does not fulfill our requirements of being at least 6 characters long. I'll also go ahead and submit an age of 12 and then hit the submit button. And it looks like our validation seems to be working, since the alert message pops up conveying the minimum length for the username. I'll just dismiss this and then specify a longer name and then hit submit one more time. And on this occasion, we get a different alert message, which includes all of the details which we have supplied within the form. So it looks like our validation check has passed. However, the form submission will only complete once our validate form method has returned true. You will know from the code that it only happens after this alert message has been dismissed. So I'm just going to click OK. And we are redirected to this HTML page, just as we had configured in our form. So we have now been introduced to the concept of forms and how we can retrieve form elements from JavaScript and then also perform a validation of form elements. Let us continue playing with our form, however. So I'm just going to go back in this page. So this has brought up our form once more. And just to be sure, we can reload this page in the browser. I'll just supply some information here for the name and the age, and then change the residency value. And we'll also update the checkboxes so that we will now select savings. I will unselect checking and then select money market as well. I'll also go ahead and switch the nationality. So with that, let's see what happens when we submit. Well, the validation has passed again, and all of the selections which we made have been rendered in this alert message. So I'll just dismiss that. And with that, the form has been successfully submitted. I'll just head back and then try a few other permutations. First, let's just see that the reset button works. So this has promptly cleared up all the fields, and the values have now gone back to their defaults. I'll just refill some of the details here. So the username here has a space within it, and we specify the age, a residency value, and in this case, I'll select all the 3 accounts available and then switch the nationality once more, this time to Canada, and then hit the submit button. So again, the validation has passed and all the details show up in the alert message. Now, what if we wanted to print out all of this information to the console as well? Alright, so heading back to the source code, we include all of these console.log messages and we print out all of the values here. And we do this after the alert message has shown up and has been dismissed, but before we return true from the validate form function. So what is the effect of this change? Well, I'll just reload the page in the browser and then resubmit some information. And then when we hit submit, sure enough, the alert pops up, but nothing is shown in the console yet. That is expected. But as soon as I hit OK, we are directed to the other HTML page. In the theory section of this learning path, we covered the fact that variables in JavaScript are created as soon as the page associated with the JavaScript is loaded in the browser, and they are destroyed the moment a different page has been loaded. So you'll need to make sure that the console.log statements appear a little earlier in the code. So we head back, select all of this, and place it just before the alert message. With this change made, let us save down everything and then reload the page in the browser. And I'll just quickly fill in some form details once more. And this time when we submit, all of the form information is available within the console as well as in the alert message. You will observe though that we can't really expand this account selected array from the console at this point. So I'm just going to dismiss this alert message by hitting OK, in which case the console is cleared up and the new page has been loaded. The validation which we have performed so far in this demo has been rather basic, since we only check whether the length of the username is less than 6 characters. In the next video, we will see how the validation can get a little more complex, where we will apply a regular expression check on the username and then perform a check on a few of the other fields as well. In the previous demo, we got introduced to the concept of form validation, where we performed a basic validation for the length of the username field in a registration form. We will now extend that example in this demo. Once again, we have a form.html defined, and this is the page which will load once a user has successfully submitted their registration form. Beyond this, we have two different files in this directory. So there is an HTML page, which is going to be an extension of the one we have already used, and then a JavaScript source file where we will define all of the validation checks. So I'll just head over to the HTML first, and you'll observe that this is quite similar to the HTML which we used in the previous demo. We have the username and age fields along with the residency, and the other fields are also the same. However, there is one notable difference. Just below the input for the username, you will observe that there is a label element with the ID of uname label. We have applied a style to this where the color is red, and we have set the visibility of this element to hidden. By default, this element will not be visible to the end user. So this has the text username should have a minimum of 6 characters, and we will set up our code in such a way where if the user supplies a username which is less than 6 characters long, we will alter the visibility so that this element is no longer invisible. Before we proceed, I'll draw your attention to the onSubmit attribute for the form, which once again invokes the code return validate form. The validate form function will again be defined within our JavaScript file, except this time it will have many more validation steps. Scrolling further down, you will observe that everything else, from the checkboxes to the drop-down, as well as the submit and reset buttons, are exactly the same as in the previous version of the form. So let us get down to the JS file, and here we will enable strict mode and then begin defining the validate form method. Just as we did previously, we access each of the input elements using document.forms, but you'll observe that on this occasion, we are not accessing their values directly, but in fact, each of the variables represents the element objects themselves. We will now get down to performing a validation for the username, and on this occasion, we're not just going to check for the length of the username, but that it also conforms to a particular pattern as described by this regular expression, where we ensure that it only contains alphabets, whether in lowercase or uppercase. And then after this, we will perform the validation of the username. The first check we need to do is for the length, and note here that since uname represents the element itself, we need to access its value from its value property. So if the length is less than 6, then we make sure that the username input box is brought into focus by invoking uname.focus. Since the validation will have failed at this point, we will also return false. Beyond that, if the username is greater than or equal to 6 characters, then we perform one more check. Specifically, we check that the value of the username field does conform with a regular expression. For that, we can invoke the test function using our regular expression string, and this will return a boolean true if the username value does match our regular expression. If there is a mismatch, however, then we go into the if block, where we will apply a border on the username field, and this is going to be a solid border which is 2 pixels in width and red in color. Following that, we set the inner HTML for the label element right next to the username field, and this is where we convey the message that the username can only have alphabets. Following that, we also set the visibility for that label element to visible. And again, we return false since the validation will have failed. On the other hand, if the username has a valid length and matches our regular expression, we move into the else block, where we apply a solid green border of 2 pixels on the username field. Then we adjust the inner HTML for the label element, conveying that the username is valid. And this text will also appear in green. We also set the visibility of the label to visible. Continuing with the validation, we next check whether the value of the age is less than 18. And if it is, the validation has failed, and we convey to the user that they must be at least 18 years old in order to open up a bank account, and then return false. Also, if the user has left all of the boxes related to the account types unchecked, then this account type variable will have a length of 0, in which case we will automatically check the box corresponding to the checking account. We access the array of checkboxes using a query selector all function call, and check the one corresponding to checking account by setting the checked attribute of the element at index 1 of this array to true. We're not quite done with the validation though, since at the very end, we will ask the user to confirm that they do indeed wish to submit the form using a confirm box. And if they hit yes, then we return true to convey that the validation is a success and that the form can be deemed submitted. Alright, we can now save down our files and then bring up the JSForm validation.html in the browser. Once the page loads, I will pull up the console on the right. And then following that, let us go ahead and enter some information in the form. So I'll specify a username of John, which is clearly not 6 characters or greater. A value of 15 for the age will also fail validation, but all of the other values are fine. So I'll just go ahead and hit submit now. And sure enough, the alert message pops up and says that the username needs to be at least 6 characters in length. The moment you hit OK though, you will notice that the cursor is now in the username field, since we had set the focus to that in case of an insufficiently long username. So I'll just go ahead and then set this to a value of John space Smith, which once again is going to fail validation, but this time due to the regular expression mismatch. And when we hit submit, the behavior which we had defined has taken effect. The username field is now highlighted with a red border, and then the text right next to it in the label element now conveys that the name can only have alphabets, and this is also highlighted in red. I'll just go ahead and remove the space now and then resubmit. This time, the alert message says that the age is not valid. And the moment I dismiss it, you can see here that the username field is now highlighted in green, and the text in the label element has also changed. Also, that element is now clearly visible. Alright, I'll go ahead and set a valid age of 19 and then resubmit. And this time, we get this confirm message since all of the validation checks have passed. So, I'm just going to go ahead and hit OK, and we are directed to the successful form submission page. Let us head back to our original page, however, and reset the fields. I will once again specify a valid username as well as a valid age. And then once again, select values to ensure that the validation checks will pass, which means that I'll ensure that at least one account type has been selected. And then let us hit submit. And once again, this confirm message pops up, and hitting OK takes us over to the form submission page. Once you begin writing JavaScript code, whether it is for the client side of your web application, or even if you happen to be using Node.js on the server side, it is likely that you will run into some asynchronously executed code. While JavaScript itself is single-threaded, there are some operations which could take a while, such as API calls, for example, which are executed in a non-blocking manner, which means that the program does not wait for that call to return before executing the next lines of code. While such behavior may be desirable in many circumstances, but there will be others where you want at least some of your code to wait for a call to be completed before it is run, while the rest of your code need not wait for that call to return with a value. In this demo, we will take a look at the use of promises as well as the async await syntax in order to implement such behavior. So we have an HTML and a JS file here, and the focus is going to be on the JavaScript source. So I'll just switch over to that right away, where we begin by enabling strict mode, and then we define a rather simple function. So this is called a regular function, and all it does is return the text hello. Next, we define a timeout function, which accepts an argument which we call message, and then this will construct a return message. The input argument will be used to construct this message, but that is something which is not going to happen synchronously, and instead, we will define the construction of the return message within a set timeout. In case you're not familiar with this, set timeout is a JavaScript function which is meant to execute a certain function in a deferred manner. So the arguments to this include a function which needs to be executed, and we will define the body of that function in just a little bit. And the second argument is the time after which that function needs to be run. In this case, we set that value as 10,000 milliseconds or 10 seconds. What exactly is meant by asynchronous execution? Well, we will get to that in just a minute. But for now, let us fill in the body of the function. So this is where we will first print out a console.log message conveying what was passed as input to the timeout function. And then we construct the return message by simply appending the text world to the input. We will then print out to the console what that return message is, and then we will get the function to return this return message. So this concludes the definition of the first version of a timeout function. So we will now proceed and define a third function called a follow-up function. As the name implies, this is meant to be executed as a follow-up to executing timeout. This also accepts an argument, which is a message, and then simply prints out that message itself to the console while conveying that it has been printed from the follow-up function. Alright, we now have three different functions defined, so let us go ahead and execute them in the same order in which we declared the functions. So first, we invoke the regular function, and its return value is captured in the variable regular return. That value in turn is passed as an argument to the timeout function, so this will construct a return message, and then its return value will be captured in the variable timeout return, and that value in turn is passed along as an argument to the follow-up function. Now I have already mentioned that JavaScript runs on a single thread, which means that all of these executions will happen in a synchronous manner. Regular function will be invoked first, then timeout function, and then follow-up function. Each function call also depends on the output returned by the previous one. So timeout function depends on what was returned by regular function, and the follow-up function in turn depends on what was returned by the timeout function. So we should expect the regular function to return the text hello. The timeout function will construct the message hello world out of it, and then the follow-up function will print out the same hello world message. Let's see exactly how this works, however, by pulling up promises.html in the browser. And once the page loads, we head over to the console, and you may observe that the results are not quite what you may expect. So we have the first console.log message, which is not from any of our functions, but right after that, the console.log message is from the follow-up function, and this returns a value of undefined for its input argument. The last two messages are from the code which we defined inside the timeout function. So even though we executed the timeout function before the follow-up function, it looks like the console.log message from the follow-up has been executed first. The reason for this is that when we included code within setTimeout, that code did not run immediately, but in fact waited for 10 seconds before being executed. During that 10-second wait, the JavaScript engine did not pause the code execution, but in fact allowed the setTimeout code to run asynchronously, and then just went ahead and executed the follow-up function. However, at this time, since the setTimeout code had not yet returned, the variable timeout return was still undefined when the call to follow-up function was made. Only after about 10 seconds did the return value actually come in, but by that point, the follow-up function had already executed, and it had printed out its input argument, which was at the time undefined. So JavaScript has executed the code within the setTimeout in an asynchronous and non-blocking manner, which means that the code execution did not wait for it to return before proceeding. Such behavior is very often desirable since you don't want your code execution to pause for every operation which takes a while to run. In our example, however, it is clear that there is a dependency of the follow-up function on the value returned by timeout function. Such dependencies can be rather common, especially if your code happens to make API calls or database queries, and then you use the values which are returned in the rest of your code. What we really want is for the execution of the follow-up function to be blocked until the timeout function returns, but if there is any other JavaScript code, their execution need not wait for the timeout function to return. So this was a demonstration of asynchronous code execution in JavaScript and how this can affect the behavior of your code. In the next demo, we will see how we can make use of promises in order to handle this asynchronous execution. In the previous video, we covered how sometimes JavaScript code can be executed asynchronously, such as in the setTimeout function, and how this could affect the behavior of our code, especially if there is a dependency on what is returned by the asynchronously executed code. So while regular function, timeout function, and follow-up function were kicked off in a synchronous manner, part of the timeout function defined within the setTimeout was run asynchronously. So how can we ensure that the follow-up function waits for the timeout function to execute completely before it is executed itself? Well, let us try one approach. So I'm just going to comment out this timeout function definition, but we'll leave all the remaining function definitions in place, and we'll also comment out the invocations of each of these three functions. We will now define one more timeout function, and this is one which makes use of a callback. So, what if we pass along to this timeout function not just an input message, but also a callback to execute after the timeout code has run? So we once again define a return message variable and make a setTimeout call. The code within the setTimeout is similar to what we had previously, where we simply append the text world to the input message, but we don't return the message right here, but we instead invoke the callback and pass to it the return message as an argument. When we make a call to timeout function callback, we will pass along our follow-up function as the callback method. So does this mean that the set timeout code will execute completely before the callback is invoked? That is, will the callback execution wait for the 10 seconds for the set timeout call? Well, there is just one way to find out. So we will now once again invoke the regular function, and we will also call the timeout function callback, passing along the value returned by regular function along with the follow-up function itself. So will the callback execution block until the code in the set timeout returns? Well, we will save down our source file and then reload the page in the browser, and immediately we see that the follow-up has finished execution, and only 10 seconds later does the code in the set timeout run. So the output is exactly the same as in the previous run. Heading back to our code, we can see that when the timeout function callback is invoked, the set timeout is kicked off, but its execution is deferred. JavaScript does not block the code execution at this point, but instead heads over to the next line of code, which is where the callback is invoked. So this is clearly not the solution which we have been looking for. So we will now comment out this timeout function callback, including the calls to both of our functions. And instead, let us redefine our timeout function, but this time we will wrap around the code execution within a promise. JavaScript promises are a very useful construct in order to handle asynchronously executed code. Each promise represents the eventual completion of a particular block of code, whether that execution is resolved successfully or whether the promise is rejected due to an error. So how does this apply to our own timeout function? Well, take a look at how exactly we wrap the code inside a promise constructor. So the function itself returns a new promise, which of course represents the eventual completion of some code, and a promise constructor takes in a function definition, which in turn has two arguments. One of these is called resolve, and this represents the successful resolution of a promise, and the other one, which we don't make use of, is in case of an error, and that is the reject argument. So working with just the resolve argument, we proceed to define the function body for the promise, and this includes the same code which we had earlier with a few minor tweaks. Once again, we have the return message variable and the call to set timeout, within which we construct the return message. But after that, we return the message not using the return keyword, but by invoking the resolve function. This will have the effect of returning a promise itself, and we can use this in order to make another function wait for this promise to be resolved before it executes itself. So now that we have our timeout function wrapped inside a promise, let us go ahead and make a call first to the regular function, and we now want this regular return variable to be passed as an argument to our timeout function with the promise, and we also want the follow-up function to wait for that promise to be resolved before it executes. So how exactly can we do that? Well, we will need to make use of the then method of a promise. So here, we call our timeout function promise, and we pass along regular return as an argument. This will return a promise object, and this represents the eventual execution of the function. Now, if we want some code execution to wait for that promise to be resolved or rejected, then we wrap this inside a then function call. The argument to then is itself a function, and the argument to that function is what is returned by the promise. Our timeout function promise returns the return message which was constructed by means of the resolve method, and this is accessible in this timeout return argument. So the code within the then function will only execute once the promise has been resolved or rejected. In our case, only once the return message has actually been returned. So this invocation of follow-up function should follow the completion of our timeout function. And to test it out, let us save down our source and then head over to the browser, where we can reload the page and then view in the console exactly the order in which the calls are made. So the follow-up function is yet to execute. It's still waiting, and we can now see that the code within our timeout function is executed first, and then the follow-up function is run. And importantly, the argument which was passed to the follow-up function was what was returned by the timeout function, so it has printed out to the console the full text of hello world. So this was a quick introduction to the concept of promises in JavaScript, and you can see how this can be used in order to handle asynchronous code execution and force some code execution to block until that asynchronous code has run. This can be very useful if you want some parts of your code to wait for the execution of a database query or an API call before it is executed. In the next video, we will take a look at how promises can be implemented using the async await syntax, which is a cleaner way of defining promises. In the previous video, we saw how we can make use of promises in JavaScript in order to ensure that some code execution waits for a particular promise to be resolved before it is run. When we did that, we made use of the then function of a promise in order to handle what was returned by the promise. We will now take a look at some of the limitations of using the then function and see how that can be improved by making use of the async await syntax of JavaScript. So let us head back to the source code and then comment out this timeout function promise because we won't need it anymore. Instead, we will define some other functions which return promises. So the first one of these is called onFunction, which accepts a single argument called arg. It includes some asynchronous code, which is defined within a set timeout. And within that, the same input argument will be returned as is within a resolve function. The promise returned by onFunction does take 2 seconds to resolve due to the set timeout. Similarly, we defined a second function called toFunction, which once again accepts an input argument, and it uses that in order to construct a return value by appending the text to. This return val is also returned inside a promise by means of the resolve function, and the promise returned by toFunction also takes 2 seconds to run. As you may have guessed, we want onFunction to execute first, and then the value which is returned by it will be fed into toFunction, and following that, the return value of toFunction will be fed into threeFunction. So this also includes a promise within which we have an asynchronous block within the set timeout. Here, the text 3 is appended to the input argument and then returned by means of the resolve method. So each of our three functions includes some asynchronous code, but since toFunction and threeFunction depend on the results of some asynchronous operation, we'll need to get them to wait for the dependent operation to complete. And of course, we can implement this by making use of the then function. So here we define another function called finalVal, which accepts an input argument. Inside a promise, that input is fed into onFunction, and then we wait for onFunction to return its promise, and then we use the value returned within the promise and feed it as an argument to toFunction. That itself will return a promise, and we wait for threeFunction to wait for that promise to resolve using the then function again. And then finally, we have a console.log statement which waits for threeFunction to execute and then prints out the value returned by that to the console. So with this finalVal function defined, we'll go ahead and invoke it by passing along the argument of 1. FinalVal will pass this along to onFunction, which will just return the value as is, and that will be fed into toFunction, which will return 1, 2, which will be passed along to threeFunction, which will return 1, 2, 3, and that is what will be printed to the console. Let's see if this is what happens by heading over to the browser and then reloading the page. So onFunction executes first and produces 1, Then 2 function gives us 1, 2. And then finally, we get 1, 2, 3. So this does work exactly as intended. But if we head over to the code, you'll observe that we have made use of several then calls. In each of these cases, our function calls are rather simple, which is why the code does not look that bad. However, the moment we have multiple dependencies and larger blocks of code, you can imagine that the code itself will be quite cluttered. Defining a sequence of promise resolutions in this manner is known as a promise chain, and while this does serve its purpose, there is some better syntax available in the newer versions of JavaScript. So let us comment out this version of final val and then define another version called final val async. I can tell you that functionally, this is the same as the previous version, and you'll immediately see that the code is much more compact and potentially easier to follow. This is because we have made use of the async await syntax. To do that, we need to define our final val async function as an asynchronous function by using the async keyword. Just as in the previous version, this accepts a single argument, and this is fed in as the argument to one function. So this invocation of one function returns a variable 1, but we have made use of the await keyword in this case. The await keyword can only be used inside an async function, and it has the effect of pausing the execution of this async function until the code which follows it returns a promise. In our case, until one function returns a promise, the code execution of final val async will be paused. Once the promise does return, however, the code execution can move on to the next line, where once again, we await the return of the promise from to function. And similarly, we also wait for 3 function to execute before the console.log message is invoked. So this is some pretty neat syntax for our asynchronous function. So let us go ahead and test that it works exactly the same as the previous version with the promise chain by calling final val async with the argument of 1. So I'll head over to the browser now and then reload the page. So 1 function has run, then 2 function, and then 3 function, followed by the console.log message. So this was a quick introduction to the concept of promises and the use of the async await syntax in JavaScript. One thing you should know about asynchronous functions such as our final val async is that we have enforced the code inside the function to run in a synchronous manner. However, the function itself can run asynchronously. So if there is any code after the invocation of final val in our JavaScript source, that may continue to run while the code inside final val async is being executed. Previously in this course, we have covered the concept of asynchronous code in JavaScript and how we can make use of promises as well as the async await syntax in order to handle asynchronous code execution. In this demo, we will make use of an asynchronous function called fetch in order to retrieve an image from the internet, and will also give you a very quick introduction to Ajax, which is short for asynchronous JavaScript and XML, and is used by client-side applications to fetch data from the server in an asynchronous manner. So we once again have an HTML and JS file, and you'll observe that within the HTML itself, we have 2 buttons. Clicking on one of them will retrieve an image using the fetch API, and the fetch API itself is similar to, but not an exact substitute for, an XML HTTP request, which makes use of Ajax. The second button on the page will retrieve that same image using an XML HTTP request object. Alright, we can now switch over to the JavaScript source file. But before we make use of the fetch function or the XML HTTP request object, let us take a look at the image which we will retrieve using each of them. So I've just navigated to the URL from which you can pick up this image, And a download link can be obtained by clicking on the free download button in the top right. You can see here that this is a rather scenic view of the Alps during sunrise. Alright, so now that you know where this image is sourced from, we can head back to our source code, where I will first enable strict mode and then set a variable to the URL for the image. So while you are free to use the same image URL, you can in fact substitute any other image in its place. What does matter is that we need to retrieve a reasonably large file. So how exactly do we retrieve this image? Well, we can define a function called fetchImage for that, and this makes use of the fetch API in order to retrieve that image. So you see here that we invoke the fetch function, and this returns a response object which we capture in the variable myImageResponse. This object has a function called blob, which renders the response as a blob. So the fetch function is something which executes asynchronously, which means that JavaScript will kick off the fetch method, but will not wait for it to return a value and will head straight over to the next line where it invokes the blob method of myImageResponse. The question is, by the time this is invoked, does myImageResponse have any data? Well, there is just one way to find out. So we can pull up our web browser and then load the HTML page in there, which of course has two buttons, and hitting the use fetch button will invoke the fetch image function which we just defined. Since that prints out the blob to the console, I'll just bring up the console itself. And we can now go ahead and hit the fetch button. At this point, we immediately get an uncaught type error, which tells us that our response object does not have a blob function. Well, the reason for this is that when we invoked myImageResponse.blob, the fetch method was still running asynchronously and had not yet returned the response object, which is why that response was undefined and it clearly did not have a blob method. So how exactly do we resolve this? Well, heading back to the source code, we can make use of the fact that the fetch method does not merely return a response, but in fact, that response is within a promise, which means that we can get our fetchImage function to await the return of that promise. So with the addition of this await keyword, the code execution inside fetchImage will wait until the fetch function has returned a promise, and only then will the console.log be executed. So let us test this out by saving down our file, heading over to the browser and reloading the page. And we once again get an error, but this time the message is a little different. What we have in fact is a syntax error, which suggests that the await keyword can only be used inside an async function, which means that we need to head back to our code and then include the async keyword for a fetchImage function. This tells JavaScript that this function does contain some asynchronous code and that we should be able to use the await keyword within that. So with this change made, let us head back to the browser, reload the page, and this time when we hit the use fetch button, what we see in the console is that a promise has been returned. And when we expand this, we can see that the promise status shows up as resolved, and from the promise value, we can see that the blob is now accessible. So we have now successfully implemented the async await syntax with a built-in JavaScript function. Given that it executes asynchronously, the fetch method can be used in order to retrieve various components of a web page in an asynchronous manner, and this includes text, videos, as well as images as we have just seen. So before we get to Ajax, we can continue exploring this blob, or we can just minimize it and then hit this XML HTTP request button and confirm that the function which it invokes has not been defined yet. So we will now retrieve the same image using Ajax, and for that we head over to the source code and then define this Ajax request method. Within that, we first initialize an XML HTTP request object or XHR for short, and this will be used in order to make an Ajax call. That call will be used to retrieve the same image, but before we get to that, let us define a handler once the image has been retrieved. So this is a function called requestListener, and this simply prints out the response attribute from the object which is returned by making an XML HTTP request. We will need to map this function to our request object, however, and we do that by using its addEventListener method. Now there are many different events which this object can listen for, and one of this is called load. When the resource requested by our XML request object has been loaded, then the recListener function will be invoked, but we specifically bind it to the XML request itself. Following that, we use the XML request object in order to make a GET request for the image using its open method, and then we send over this request by invoking the send function. Alright, let us now save down this file and then reload the page in the browser. Once that is done, we can confirm that we are still able to use fetch in order to retrieve the image blob, and the promise is returned here. And now we will get the same image using an XML HTTP request. And in the console, we do get to see the response which was generated by making that request for the image. So we have now successfully made use of Ajax, specifically an XHR request, in order to retrieve a resource. So just to see another way of performing the same operation, we head back to the source and then get rid of this requestListener function. And instead of adding a listener in this manner, we will define the onload attribute of our XML request object. And this is one which will print out the response attribute of the return data. So this is similar to how we attached listeners for various elements of our DOM earlier on in this course. So to test it out, we head over to the browser and refresh. I'll just hit the use fetch button once and then make an Ajax request for the same image. And the response is returned just as it was before. So this was just a very quick introduction to Ajax. And as with some of the DOM elements, there are many different events which you can listen for using an XHR object. Going into those is beyond the scope of this course, but do feel free to explore them on your own. In this course, we covered a common use case for JavaScript on the client side of web apps, namely form validation. We looked at how user input can be defined in HTML, how these input elements can be retrieved from JavaScript, and how their values can be validated. We also touched upon the handling of asynchronous code execution in JavaScript and how these can affect your application. We examined the use of promises to manage asynchronous code and then looked into the async await syntax to make it easier to work with promises. You have now completed this learning path for the JavaScript deep dive and can consider yourself quite the expert on JavaScript. You are now in a position to begin developing real JavaScript applications for your own organization using best practices.